everyone. Today, I want to share with you my recent project. It's machine learning algorithm, logistic regression. And our project goal is to according the historical data and predict the next year's credit. That is for 0 means good and 1 means bad. So according to our dataset, let's first see our dataset. This is the dataset. It's 1,000 rows and it has 30 columns. For these columns, it's information about the account number, default. The default means that the default credit of the customers. Limit is the maximum number they can use, and the annual income and when the amounts they booked at the bank and their gender, age, education, industry, those private information, and then it's OS means outstanding. That means the maximum number, max money they just didn't pay for the bank. The due means the day of people who didn't pay the money. That means due day. Payment means the max payment money every month. So there is 7 months, and so we just do the machine learning. So let's see. So in order to use the logistic regression, we need to use this ancillary package. So we just first import them, all of the package that we need, and then we read our data, and we can check our data, every column and rows, and so this is the general algorithm of our data. Now, so we can see that there is a limit, the mean limit at 2,000, and we can see that outstanding we have the negative numbers and zeros. So now we need to check our data and get our variables, but if we can see, we need to use the those kind of variables, and we need to create them. So the limit utilization, that means the outstanding over divided by the limit. But if we have the limit equals 0, that's not good, so we need to deal with them. And also for the repayment rate, if we have the outstanding data is equals 0 or less than 0, so we need to deal with that. But now in my solution, because if people just use the outstanding delete by the limit, and if the outstanding is 0 or less than 0, that means they didn't have the money need to pay for the bank. So at this time, for this limit utilization, we can just set it to 0. And for the repayment rate, if people just have the outstanding is 0 or less than 0, that means that they just didn't need to pay for the bank. So at this time, we can set this pay ratio equals 1. And for this monthly overdue number that have several sizable numbers, for example, 0, 1, 2, 3. For example, for 1, that means they didn't pay the back less than 30 days. And for 2 means they didn't pay the back greater than 30 days and less than 60 days. So at this situation, first we just organize our data. We can see that at 0 and 1, so we have much more data, much more samples at 1, but less at 1. So it's not balanced data set. So we just first get the private information like the annual income, month of a book, and age, education, and industry code as a data set. First, we need to just calculate it. At this time, because it has so many levels, we don't want to analyze all of the levels. So we get the sort of data and group them. So if we just need, so we just need to use the top first or top 2. Then we just can set 2 levels or 3 levels. It's the same for education. We just choose the first or 2 as the level 1 and then others. So for annual income and age, those kind of it's numerical data, and we need to first use Bing to separate them to different category, and then we just get the dummy variables to deal with this kind of those kind of data types. So we just transfer them to categories. Now for the due variable, first we get all the due columns, and then we just calculate that and get the count numbers. This is the due count. It means that for the 7 months, we get the count of the due months. For example, this person every month it have dues, so we count that and get the number 7. This is max recent. It means that for the recent 3 months, the biggest due day for this person is 1. So we get the max numbers. Now we calculate the limit utilization. This is equal to outstanding divided by limit rate, and divide by limit and get the rate. And then because we organize the limit number all greater than 0, and so now we need to replace the number less than 0, less than equal than 0 to 1 to 0. So we get those mean and max and mean numbers for this limit utilization variables. We choose these 3. So we get this data set, CRE data set, those 3 variables. And then we now create the repayment rate variable. For the repayment rate variable, it's outstanding divided by the It's payment divided by the outstanding. So at this time, the outstanding have numbers less than 0 or equal than 0. So at this time, we need to replace those kind of rate as 1. So at this, first I just replace those less and equal than 0 numbers to payment number, and then payment number divided by payment number get 1. So this is the result. We get the number, the variables, and then we calculate them using the max number, mean number, and mean number. So we choose these 3 variables into our model. And then we just merge the dataset we get and get the final dataset. So we have the age, annual, mouse or bank, and due count, max recent, gender, and UR, and also the pay rate. So at this time, we need to get the dummy variables for the age, annual income, and their mouse or book, and then gender. Now, hooray, we just get the final result dataset, and then we use our model. The first model is GLM model. So this GLM model, we run that. We choose the binary binomial family, and then we get this result. We can see that for the p-value, just max recent is equal to less than 0.05. So this max recent is statistically significant, and others, those kind of are not statistically significant. Just age, annual income, mouse or book, and gender. These variables are statistically significant, and we get the log odds ratio. At this time, max recent is 2.73. So we can get the log odds ratio. It's the weight. It's 2.4, and the log odds ratio for mouse in book is greater than 145, is 4.3. So we use this multiple logistic regression, and this time we split the data into 2 datasets. One is training dataset, the other is testing dataset, and the test size use 0.3. So we get the result here because it's a balanced dataset. So for now we can see we use F1 score better than the accuracy. For F1 score, we can see the samples, their credit is good, it's 0. We just get the higher F1 score, and for the one that's bad, we get the lower F1 score. But F1 score is higher, nearly equals 1 is better than nearly equal to 0. And for this is the training dataset. For the testing dataset, it's also we get better, and credit good, and not so good at 1. This is the confusion matrix. We can see that for the actual 0, that is actual good credit, we predict is better. Now now we just calculate their scores. We can see using this scoring logic, we calculate the score, and the sample score mean is 27, and the standard deviation is 101. So the max is 1,285, and the mean is 708. And then this we called the testing dataset. This is the testing dataset score. Now we finished our project, and just to summarize that our model is good for credit. It's good, and for the credit expand F1 score little less, a little smaller, and we can got that for the age and also annual income and most recent 3 months credit. Those kind of variables are very good and statistically significant. But for the pay rate and payment rate and the limit utilization, it's not so statistically significant at this project. Thank you.